This is Spacetime, Series 23, Episode 54, for broadcast on the 3rd of June 2020. Coming up on Spacetime, the brightest explosions in the universe, the mysterious X-37B Space Shuttle launches on another classified mission, and Virgin Orbit crashes and burns on its maiden flight. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Mystery still surrounds events known as superluminous supernovae, which are the brightest explosions in the universe. Over just a few short months, these spectacular events will radiate as much energy as our Sun will deliver over its entire 12 billion year lifespan. And trying to find out exactly what's causing these stunning events has become a sort of holy grail for many astronomers. One of the most studied superluminous supernovae was SN 2006 which was first observed in 2006. It showed signs of interaction between the supernova explosion itself and circumstellar material that had previously been ejected by the progenitor star. Many hypotheses have been put forward to try and explain the immense power of this supernova, and in 2009, astronomers detected unusual emission lines in the spectra from the event. Spectra can provide scientists with the chemical composition, temperature, and even speed of gas surrounding a star. And the spectrum from SN 2006 showed signatures of elements never before seen in a supernova explosion. The origin of these spectral lines and their significance would remain a mystery for more than a decade. But now, scientists have finally identified these spectral lines as originating from, of all things, neutral iron. The study's lead author, Anders Jerkström from the Max Planck Institute, says this low-energy state of iron is typically not seen in supernovae, where the high energies involved tend to strip electrons from their atoms. Jerkström says that normally a supernova expands too fast for individual iron features to be clearly seen, and this particular set of spectral lines had never been seen before in any kind of astrophysical nebula. So SN 2006 has some truly unusual physical properties. News that the spectra mostly consists of iron excludes several previously suggested scenarios. And it's not just a little bit of iron the authors are talking about. They've calculated the amount of iron being seen here equates to around a third the mass of the Sun. Importantly, that means that this blast most likely wasn't a core collapse type 2 supernova, which happen when stars far more massive than the Sun explode, but more likely a thermonuclear type 1a supernova, which happen when white dwarfs, the stellar remnants of smaller stars like our Sun, explode after accreting too much material from a neighbouring star. The authors think the progenitor was a double star or binary system, consisting of a white dwarf in a close orbit with a more massive hydrogen-rich companion star. As the hydrogen-rich star expanded, the white dwarf became trapped in its atmosphere, eventually spiralling in towards the larger star's centre. In the process, the envelope was ejected. And once the white dwarf reached the core of the other star, it exploded as a core collapse supernova. The expanding shockwave of this supernova then collides with the previously ejected envelope, and in this gigantic collision, extremely intense light is radiated. By modelling this very scenario, the authors could reproduce almost exactly the key properties of SN 2006 importantly including the unusual neutral iron signature. This is Spacetime. Still to come, the mysterious X-37B Space Shuttle launches on another classified mission, and Virgin Orbit crashes and burns on its maiden flight. All that and more still to come on Spacetime. The United States Air Force has launched one of its mysterious X-37B Space Shuttles on another classified orbital mission. The delta-winged autonomous spaceplane was carried aloft aboard an Atlas V 501 rocket equipped with a Centaur upper stage from Launch Complex 41 at the Cape Canaveral Air Force Station in Florida.
Launch enabled, 137.
FTS arm.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
OC's armed.
FCS count started.
Reduce ECS for launch.
Roger. Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Range green.
Yes, reduced for launch.
Status check.
Go Atlas.
Go Centaur.
Go Space Force 7.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket with USSF-7 for the United States Space Force on a mission dedicated to America Strong.
RD-180 has gone to closed-loop propellant utilization control.
You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
The pitch yaw roll program. Now, 35 seconds into flight, Atlas is now just under 1 mile in altitude, traveling at 900 miles per hour. Engine pump speeds and injector pressures are in family for this thrust level. The vehicle has now completed the pitch yaw roll program. Now, 70 seconds into flight, Atlas is now 4 miles in altitude, 0.4 miles downrange distance, traveling at 1,200 miles per hour. Vehicle has passed Mach 1. Vehicle is now passing through maximum dynamic pressure, max Q. RD-180 is now throttling down slightly as commanded. Speed response looks good. We're now 14 miles in altitude, 5.6 miles downrange distance, traveling at 2,000 miles per hour. Vehicle has now begun closed-loop steering. The vehicle is now half the weight it was at liftoff, burning propellant at a rate of more than 2,600 pounds per second. Approximately 2 minutes remaining in the Atlas booster phase of flight. Sensor reaction system is now pressurizing flight levels. Atlas is now throttling to maintain 2.5 G acceleration limit. Now 180 seconds into flight, vehicle is 44 miles in altitude, 40 miles downrange distance, traveling at 4,500 miles per hour. Standing by for payload fairing jettison. With indication of payload fairing jettison. And sensor forward load reactor has also jettisoned successfully. Atlas is now throttling up to a 4.6 G acceleration limit. Centaur has begun the boost phase chill down sequence. Atlas is now at 4.6 Gs and maintaining that acceleration limit. EU has gone to closed loop control. Boost phase chill down is complete. We have BECO booster engine cutoff. Standing by for stage separation. Stage SEP, we have successful stage separation. Restart on the RL-10. We have ignition, MES 1. Centaur has now begun the first of 2 RL-10 burns in today's mission.
The US Space Force 7 mission, formerly OTV-6, is carrying more science payloads than any previous X-37B flight. That meant the addition of a service module for the first time docked to the X-37B in order to increase capacity. Included in the manifest is an experiment in the true spirit of Nikola Tesla, designed by the US Naval Research Laboratory to convert solar energy into radio frequency microwave energy and then, and here's the Tesla bit, transmit that energy down to Earth. The mission's also deploying a US Air Force Academy Falcon Sat-8 research satellite, which is carrying 5 classified scientific payloads. And there are 2 NASA experiments on board the mission as well. They are not classified. One's looking at the effects of space radiation on seeds, while the other will assess the performance of various materials in the space environment. And that suggests another long-duration spaceflight for this X-37B mission. Of course, the last mission, which ended in October, lasted some 780 days in orbit. Prior to this latest launch, the 2 X-37Bs have flown 5 missions, totaling a combined 2,865 days in orbit, all of it in total secrecy. The X-37B is a small reusable delta-wing spaceplane developed by NASA and Boeing in 1999 and designed to be launched from the payload bay of NASA's Space Shuttle fleet and then fly autonomously into other orbits. The aerodynamic design of the X-37B is based on that of the Space Shuttle, and it carries enough power to give it a delta-V, allowing it to undertake significant orbital maneuvers, including the deployment of satellites from its own payload bay in orbit, rendezvousing with other spacecraft to perform repairs and modifications, or to retrieve orbiting satellites for return to Earth. The project was transferred to the US Department of Defense in 2004, and in 2006 the Air Force announced plans for Boeing to construct 2 updated versions called the X-37B, with the first undertaking its maiden flight in April 2010. Speculation about the orbiter's clandestine payloads have ranged from testing new generations of advanced reconnaissance and spy sensors in order to see how they survive long-duration spaceflight, through to trials of new EM-drive electromagnetic microwave thrusters, and even missions to attach electronic surveillance countermeasures technology onto enemy spy satellites. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
X
X-37B, the space plane, Fred. This was launched from Cape Canaveral, and this is the all-mysterious unmanned remote control solar flying vehicle that I think in its last mission was in space for over 700 days.
That's right. It's always intriguing when this remarkable vehicle is launched because we don't know why it's going. The last
which makes it hard to do a whole segment on.
Well, that's right. No, look, we can make up all kinds of things. The last time it was launched, this extraordinary space shuttle, it's a quarter of the size of the traditional NASA space shuttle. It, in fact, was originally designed by NASA, but was very quickly taken over, I think, by DARPA, the Defense Research Agency in the United States, and promptly became top secret. It's called the X-37B, but basically is a quarter-sized replica of the space shuttle, a few design changes. It launches on top of a standard rocket, and if I remember rightly, this one is on top of an Atlas rocket from the United Launch Alliance. Yes, it's an Atlas V rocket, and it's also got another national security satellite in the payload bay. But as you said, launched successfully on Sunday, declared a success an hour and a half after liftoff. It would be well into orbit by then because it only takes, less than 10 minutes usually to get to orbit in some of these things. That's an initial orbit, but it's probably in its final orbit now. So the last time it went up when the media asked the defense agencies what its mission was. The answer was testing.
Yes.
And
that's an open-ended answer. Yeah, testing.
Testing, yeah.
That could mean anything.
Yeah, that's right. So the missions are all about checking out technologies and things of that sort. And one reason why it excites me that this sort of thing is taking place is because you can look back on technologies that have been developed for military space missions, which are now common parlance in civilian space flight. So whatever is learned from the X-37B mission might very well stand us in good stead one day, and the sooner the better in terms of, how you maneuver in space. In fact, I think the original mission for the X-37B, if I remember rightly, and it's several years ago now, was to look at the dynamics of orbit changes, how you can be nimble in orbit, because changing the orbit of a spacecraft is not a small matter. You've got to put a fair bit of oomph into it to shift it, particularly if you change the orbital inclination. So I think that sort of thing is the sorts of experiments that have been doing. The home base of the X-37B, and there are two of them, which are operated by the Air Force. Their home base was the Space Shuttle hangar at the Kennedy Space Center. So, they've gone for miniaturization. And just to put a few statistics into the story, first flight was in 2010, further back than I thought it was. It's these things creep up on you. And totally, so far, they've totaled 2,865 days in orbit. One of the spokespeople, Jim Chilton, who is the senior vice president for X-37B at Boeing, he said a number of things that are quite nice comments on this, as much as you can say. The X-37B stands on the shoulders of the Space Shuttle, and from a common shape to a common home. That's his reference to the fact that it lives in the Space Shuttle hangar at Kennedy. But what he also says is if you add up all the missions, just under 8 years in orbit and 1 billion miles, so a lot of traveling by this machine. Quite interesting stuff.
Incredible. This aircraft or spacecraft was built by Boeing, which might surprise a few people. It's a Boeing plane. And when you go to the Boeing website, it's got on the front page, it says purpose, the purpose of the X-37B. It's 3 lines. It's a 3-line explanation of the purpose of the X-37B.
Yes.
So they're not letting a lot of information get out too far. And when you're talking about a vehicle that's operated by, the US Defense Department and Air Force through the Pentagon, it does sort of set off a little alarm bell in the back of your head. What else is going on up there is the first question that pops into many minds, I'm sure.
That's right. This is just the tip of the iceberg. This is just this exhibit having a replica, which we should mention is completely remotely controlled. There are no passengers on board, but a replica of the Space Shuttle doing extraordinary things in orbit and then doing its landing in exactly the same way that the space shuttle did, gliding down to a touchdown. Remarkable stuff. The only other thing I was going to add to the comments, Andrew, is that I think this launch of the X-37B was under the auspices of the new Space Force in America, even though I think it's operated principally by the Air Force. But I think I'm right in saying this is the second rocket launch for the newly established Space Force. The first one was back in March. So the Space Force has got its got its fingers in this pie as well. I wish we had. It'd be lovely to know what it's up to.
Yeah, and once again, anything involving space comes up with a fantastic name. That sounds like something from a B-grade science fiction film, The Space Force.
Space Force, I know it does.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Spacetime. I'm Stuart Gary. Still to come, Virgin Orbit crashes and burns on its maiden flight. And later in the science report, radiocarbon dating, long used to determine the precise age of ancient artifacts, is being recalibrated. All that and more still to come on Spacetime. Virgin Orbit's new LauncherOne rocket system has failed during its maiden flight. The rocket was carrying a dummy satellite for the demonstration flight, which was supposed to be placed into low Earth orbit. LauncherOne is a 21.3-metre tall two-stage launch vehicle developed by Virgin Orbit and designed to carry small sat payloads of between 300 and 500 kilograms into 500-kilometre high sun-synchronous low Earth orbit. The original plan called for the use of Virgin Galactic's White Knight 2 mothership, used to deploy the Spaceship 2 space tourist suborbital rocket plane to deploy LauncherOne rockets from high altitude. But as the mass of the LauncherOne rocket and its payload continued to grow during the development phase, a larger, more powerful aircraft was needed, and so Virgin used one of its spare Boeing 747-400 jetliners instead. The modified jumbo jet, nicknamed Cosmic Girl, is equipped to carry the LauncherOne rocket and payload in a specially attached pylon cradle under the port wing next to the fuselage. This is a hard attachment point on Boeing 747s normally used to transport spare engines. The mission lifted off as planned from the Mojave Air and Spaceport in the desert north of Los Angeles. It then headed out over the North Pacific Ocean just beyond the Channel Islands and began flying an oval-shaped flight path known as the racetrack. LauncherOne's onboard computer took control of the mission a few minutes before the final countdown, and a maneuver in which the 747 pitches up steeply and releases the rocket at an altitude of about 11,000 meters or 35,000 feet before banking away and allowing the rocket to freefall for a few seconds before ignition. Virgin Orbit says it was a clean release and LauncherOne's engine ignited just as planned. It started to maneuver, and then all of a sudden, everything went wrong. The company says they'll try again once they've determined the cause of the failure. It says a second rocket is ready to go and 6 more are under production, with Virgin claiming to have dozens of customers waiting to launch, including the US Space Force and the Royal Air Force. A full investigation to determine the cause of the failure is continuing. Here's how Virgin Orbit describes what happened.
So our team got to the launch site very early in the morning. We prepared our rocket, we prepared our airplane, we went through our checks of our mission control center, and we got into our operations. The launch team then walked out and checked out the ground equipment, and we flowed propellant into the rocket. We verified that everything was healthy, and then we disconnected it. And our flight crew boarded the airplane and taxied out and took off from Mojave Air and Spaceport. We climbed to first 10,000 feet, did our initial checkout, and then went up to our flight altitude of 35,000 feet, entered a racetrack pattern. The system then moved automatically through pressurizing our propellant tanks, activating our systems. The pilots then pulled up the 747 and dropped the rocket off the airplane. The rocket then went into a control mode. As it moved through the atmosphere, we ignited the first stage. We then guided the rocket to its trajectory, and at that point we did have an issue in the system and the engine shut down. Clearly some disappointment that we didn't get to finish the flight and take it to orbit, But we were all prepared for that. We collected an enormous amount of data, verifying air launch, separation of the rocket, control of the rocket. We've got an enormous amount of data about the aerodynamics in free space, in powered flight, and we verified our controls algorithms as we guided the rocket with our first stage engine. Our engineers are pouring through the data now. We'll be applying lessons learned to our next rocket, which is right here in the factory being prepared. We'll make whatever modifications we need to, and we'll get to the next flight.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A trial of 199 patients with COVID-19 has found that a combination treatment used to treat HIV-AIDS patients has no benefit for adults with severe COVID-19. A report in the New England Journal of Medicine says doctors had hoped that the combination of lopinavir and ritonavir, which are sold under the brand name of Kaletra, might hold promise in the treatment of COVID-19. Instead, the study found there was no difference from standard care in the time to clinical improvement. Mortality rates were also similar, and the percentages of patients with detectable viral RNA at various time points were also similar. A new study claims anti-obesity medications such as phentermine and topiramate, used individually or in combination, can significantly reduce weight gain in patients following gastric bypass surgery. The findings, reported in the journal Obesity, are based on medical records of nearly 1,200 patients who underwent gastric bypass surgery between 2004 and 2015 at Boston Medical Center. They found the anti-obesity medications decreased weight regain by 10%. Weight regain following gastric bypass surgery is well recognized, normally occurring 2 years after the surgery and ultimately affecting up to 25% of patients. Radiocarbon dating, long used to determine the precise age of ancient artifacts, is being recalibrated. A report in the journal Nature says the change, the first in 7 years, could shift the age of some prehistoric samples by hundreds of years. The recalibration is based on thousands of data points from tree rings, corals, stalagmites, and both lake and ocean sediments. It extends the time frame for radiocarbon dating back to 55,000 years ago. That's 5,000 years further back than the last calibration in 2013. Radiocarbon dating is based on the absorption of carbon, including the isotope carbon-14, by all living things. But of course, living things stop absorbing it when they die. And so the ratio of the accumulated radioactive carbon-14 changes as it continues to decay, giving scientists an indication of when it died. See, the dating technique assumes that the ratio of carbon-14 in the environment has always been constant. And that's the problem. Atmospheric nuclear weapons testing and the burning of fossil fuels has affected this ratio. Planetary magnetic field reversals, which have allowed more solar radiation to increase carbon-14 levels, and hemispheric differences in the amount of carbon being absorbed by the oceans, also needs to be considered. Remember, there's a lot more ocean in the southern hemisphere than north of the equator. Consequently, new conversion tables, better matching calendar dates with radiocarbon dates in different regions, now need to be developed. A new study may help explain why it's so hard to wake up and get out of bed on a cold winter's morning. Neurobiologists at Northwestern University uncovered a clue about this behaviour during a search on fruit flies. They identified a built-in thermometer circuit that relays information about external cold temperature from the fly antenna to the higher brain. A report in the journal Current Biology claims researchers found that through this circuit, seasonally cold and dark conditions can inhibit neurons within the fly brain that promote activity and wakefulness, especially in the morning. And that's the show for now. Spacetime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download Spacetime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the Spacetime online shop and grabbing yourself a few goodies, or by becoming a Spacetime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at Spacetime with Stuart Gary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.